Okay, here we are, lesson 19, last lesson of this unit. So here we are going to still be looking at scale factor, but now we're going to dive into area of scale factor and try and figure out a little rule that will help you. So I'm going to go through a couple examples and we're going to see if we can figure it out. So here's example one, and they give us an actual picture in our scale drawing. We need to figure out a couple things. So I'm going to start by figuring out my scale factor. So I'm going to divide 6 divided by 3 equals 2. And then I'm going to divide 8 over 4 equals 2. And so I see that my scale factor is 2. You guys, I picked those numbers by looking at the units on each of them. And I compared, so this corresponding length divided by this corresponding length, this corresponding side by this corresponding side. And because they came out to the same number, I know that my scale factor is 2. So now I need to figure out my actual area. So area equals length times width. So my actual picture area equals 4 times 3. So my actual area is going to be 12 square units. My scale drawing area is going to be 8 times 6, which that is 48 units squared. And now I'm going to look at the ratio of my scale drawing area to my actual area. So I'm going to divide 48 units squared over 12 units squared. Just like I did here, I had my scale drawing divided by my actual drawing, scale drawing divided by actual drawing, scale drawing divided by actual drawing. And I'm going to see that my area is 4. My actual ratio is 4. And so here I'm going to compare my scale factors to my actual area is 4. So let's keep that in mind as we go through the next example. Oops. So my next example, the actual picture to the scale drawing is smaller. So I'm going to guess that this is going to be a reduction and it's going to have a scale factor that's a fraction. But I'm going to show you to figure out my scale factor. I'm going to divide my scale drawing length, 3 units, by the corresponding length of 9 units, and I'm going to get 1/3. And then I'm going to do that for the other length side. So 2 divided by 6, which also equals 1/3. So my scale factor is 1/3. All right, so my actual area is going to be 6 times 9, which is 54. And then my scale drawing is 3 times 2, which is 6. And then I'm going to compare my 6 over my 54, my scale divided by my actual, and the ratio here is 1/9. So I now have 1/3 compared to the 1/9. Let's do one more and see what we can find. Okay, so now we have a triangle, which is going to be a little more difficult, but we can do this. Scale drawing, actual drawing. Divide my scale drawing by my actual drawing corresponding lengths. What is that going to be, you guys? 12 over 9. What is that fraction? We're going to go ahead and just reduce it and leave it as 4/3. And now I have to do my 8 over 6, which equals also 4/3. So my scale factor is 4/3. All right, now my area, well, area of a triangle is area equals 1/2 base height. All right, so my base is 6, my height is 9, so 54, and then 1/2 of that, which is going to be what, guys? What is that going to be? That is 27. So my actual area is 27. All right, then my scale drawing. 12 times 8, and 1/2 of that. So 1/2 of, what is that? 8 times 12 is, let's throw that in a calculator, you guys. Calculator. 12 times 8, 12 times 8, 96. So 1/2 of 96 is 48. So my scale drawing is 48. My value of the ratio, I have to compare my 48 over 27, which can reduce down to 16/9. Okay, I'm going to pause this video, upload it, and then we're going to come back and talk about these different scale factors.